Hey, welcome to the lab today. Working on a comparator circuit. Right there. It is based off of a TLC 352. And then I also have LT 1004 1.2 volt in there. I'm trying to design this comparator circuit for a nickel metal hydride boost converter to go to USB. And I wanted to show you guys some of this. My particular converter has two cells. So I'm driving it with a Tektronix function generator. And on the generator, we've got I've got a little power supply just for a little amplifier off of it. I can show you guys that schematic a little bit differently. Anyway, so I'm amplifying the function generator. I figured I probably didn't need to, but I figured I'd be safe anyway doing it. And then I got that TLC 352 in there. And then my 1.2 volt reference is a D1004 1.2 volt. So what I really wanted to show everybody was really what hysteresis is. And it's that right there. So well, how do I say this? I guess if you can see, I've got this in XY coordinates. So each X is my input voltage. The Y is my output voltage, or my comparator voltage. Okay, so as my voltage goes up, you can see how it deviates just a little bit right in there. Well, that high voltage there, when it goes high, you can see it come down there, and it deviates a little bit. It takes a little time to settle out. And then as the voltage gets higher, I'm keeping that voltage low, and then it starts coming back, and it actually gets lower than what it tripped at. It gets just a hair bit lower. And when it gets that little bit lower, it pops back up, and I got high voltage there. Now this is what's called a inverting comparator. So as my voltage gets higher, my output voltage goes low, and as my voltage goes low, my output voltage goes open drain in this particular case. So that's kind of how this thing works. I'll show you also, for those of you kind of challenged with XY coordinates. But if I was to zoom into this really close, and it's kind of hard on this scope, but you'd see these vertical lines here where it's actually tripping down and then it's tripping back up. Okay, so if I zoom out a little bit and I actually show you, what it looks like, and let me offset them just a hair. So the top one there is my input voltage. As my input voltage goes high, my comparator trips low, and then as my input voltage goes low, it trips high. So I've set this to trip right to go high right around 2 volts, and to go low right around 2.4 volts. The particular boost converter I'm using has a shutdown pin that is an active low. So if you pull it low, up, pardon me. Yep. If you pull it low, it turns on. Actually, that's a lie, but I need it this way so that I can use a transistor to switch it, and I've got a couple other things going on there too. So that's really what's going on. Alright, so I hope that's somewhat educational. Talk to you later.